Yeah, my favorite. Okay, so welcome back. There's the following thing I'd like to do. I will post this link. So hopefully you have a device with you. So I have a number of prompts here. We're going to do this step by step. I have a data set, probably fake. It's simulated data for a typing speed experiment. So it's people typing whatever text or something with different, I don't know, devices. We've discussed this before, and it has a couple of useful dimensions in it about number of typos they make as the outcome variable. As a function I'm interested in for this exercise, as a function of the speed with which they type. Okay? So let's start by, well, obviously loading this in and visualizing the relationship between number of typos and typing speed. Number of typos, the outcome, y-axis, typing speed, x-axis. And then run a regression analysis on the pool data and interpret the results. So step one, yes. I know. Not necessary. There's nothing else in it except the prompts.
Would be easier to copy paste the prompts to the agent. I think
Put some, effort into it.
it's very different object.
I suggest R, by the way, for this, just because the plots will be prettier. But do whatever. Also, yeah, I don't know how you do, but you probably can do mixed regression in Python. You could probably do that in Python.
Also, a R2 library, which lets you run R.
Oh. So you could do it in VS Code instead of in RStudio? Is that the idea?
Yeah. There's a IPython kernel extension.
Yeah, which is what I use. Except the VS Code, whatever thing is broken. So, the agent thinks it has made changes to your R notebook, but in fact it has not. So like there's something about changing the file is broken or refreshing.
Oh, if you're writing it like as a notebook, like with cells, that issue happens.
Yeah.
But if you're writing a full RMD file,
yeah, so like the notebook experience is broken. Okay, so this should be hopefully quick and easy. I put a link to the file in Slack. You feel appreciated at grad student appreciation day? Did you give you anything except the free lunch? Better than nothing.
I appreciate it.
It is good. Good. Me too.
The cake was really good.
Cake was good. I find these supermarket style cakes be always too sweet.
I agree with you. I thought it was good.
I thought the frosting was great.
I think that I agree with the cake thing, and it's also the same for cookies, like the little frosting cookies. Except those ones are that's a good, you're not getting so much sweet. It's like
I agree. That's like a good balance.
Yes.
I agree.
Yeah.
I feel like the frosting is always worse on those cookies.
Okay.
I feel like it's
You
the
get
same.
cake frosting and you put it on the cookie.
I think it's the same thing.
The same thing. Well, they definitely taste different.
Like,
No,
Speaking of cake, did you see? So Nadia defended her thesis yesterday. Did you see the cake she had? It was wild. Like literally. I think one of her friends made it for her. Let me see.
what does it mean to estimate the noise terms? Like in your simulated data, you also have estimated noise.
I do.
EX and Y. That doesn't mean anything.
Ignore. Maybe it's just the simulated data. So like these are the simulated error terms.
Yes.
There was probably some regression equation plus some simulated noise that created the data, maybe. I don't remember. I did this a while ago. Ignore all the other columns except the two that we care about here.
That is speed, typos and files.
Yeah, just two columns. So how are we doing? Anybody want to share? We're not at the trick part yet, so you're safe for you to share. I'll tell you when I trick you, as always. There's no tricks here. So we can't get stuck just yet.
The R-squared relationship a weak one?
When is it a weak one? It ranges between 0 and 1.
Okay.
So when it's a weak one, it's a judgment call. There's some magic numbers you can refer to, but largely it's a judgment call. Oops.
How do you validate that judgment call? I feel like it's the voice.
You validate the validity of the specification of the model. So this is the stuff we talked about earlier. You look for residuals and patterns therein. You look for high leverage points. You do a bunch of these other diagnostic tests. That's the validation more than the bit value itself.
That says I'm sharing, but I don't think.
You want to try again?
I'm sharing.
You are sharing?
On Andrea's screen, you over, like, there's Andrea's screen on top.
Oh.
Yeah.
Oh, there's different tabs now? Oh.
Because multiple people can share together, so you can just choose each tab.
Oh, that's fancy. Oh, thank you. I didn't know that. Okay. So you read the data set and you plotted typing speed. Can you do it the other way around? So like number of typos as the response variable on the Y? Yes. Same for the plot, I guess. In and the order of the arguments, is that right? I don't know the syntax for this. So in your plot call, it's number of typos first and typing speed second. Does that mean one's X, one's Y? I also, can somebody make this?
Your model, I think that this is like the thing you're trying to predict.
No, I know, that one I know, I'm sure of.
Okay.
In the next one below that, the plot one, which one's first? Is it X or Y? Does anybody know?
I'll switch it, just
It should match.
And so that's.
You press zoom a little bit, actually can see the code.
Yes, thank you, that's a good idea.
Wait, what is it?
Can you zoom in, make it bigger? Command plus, bunch of times. Yeah. Let's confirm the order of those arguments there. Let's see. R plot function arguments. Core data arguments, X comma Y. What do you have? Wait, what happened to, did we lose your screen? Oh. Can you zoom, yeah, here, X comma Y, first one's X. So typing speed is X, number of typos is Y, perfect. Okay, so I'll read this for me. Interpret. Yeah, please.
I think it's that the number of typos goes up, the faster the typing speed is. Or sorry, it's the number, no, never mind.
The faster you type, so the faster you type,
Yeah.
the fewer typos you make, the lower the typos.
Well, this was like a correlation thing, not like a.
Yeah, what are the units on typing speed? There can't be negative time.
Well, this says for every 1 unit of typing speed you go up, it goes down some unit of typos, right?
They've both been normalized,
Yeah.
like before. So mean zero, standard deviation 1. It doesn't, it just shifts, but it doesn't change the nature. So the interpretation is the same. It doesn't matter what scale it's on. And that's it. The unit changes. Like this is units of standard deviation now instead of actual units.
What is it, words, was it words per minute or time between words?
Words per minute. Yeah, let's say words per minute. Yeah. So the faster you type, the fewer mistakes you make. It's what it is. The data does not lie, does it?
And it's under linear regression settings, and we can actually observe very few outliers, most of all being
Mhm. Yeah, so it looks pretty clean. Yeah, Andrea?
Isn't this like where the concept of like the mixed stuff comes in?
Good,
Because
yeah.
Or like if you look at the CSV, there's a bunch of different results for each participant.
Yeah, we'll get into that in a second. Can you show, before we get into this, can you please show just the linear regression model you estimated, which is the other tab there, maybe the middle one? Maybe this one? Yeah, so we estimated the linear regression model, number of typos as a function of typing speed, and it says that for every unit increase in typing speed, you get 0.6 fewer mistakes, which is just a way of, analytically expressing the thing we saw in the plot before. And this fits, reasonably well. Okay, so pretty good. Right? But counterintuitive, does not make sense. Right? Because how could that be? What's the mechanism? It's exactly. So this is the kind of skepticism that you should have when you do something like this, right? So the first thing you should ask yourselves is, okay, what's the mechanism, right? So then you sort of, argue logically through the mechanism, the typing, whatever, like there's no way, right? So it makes it very implausible that this can be true given what you know about the mechanism, right? There's no way you can be more careful and as you're typing faster, right? There's no way, like, surely. So what's going on? What's going on is we have pooled all of the observations from all of the study participants. So as it turns out, if you look at the input raw data, you will notice that we have 50 participants, and for each participant, we have 50 observations each, maybe as part of the experiment. So there's probably 250 rows in this. 2,500 rows, sorry, yes. 50 times 50 rows in this. So something else must be going on here that we're not yet capturing. Okay, so let's explore that a little further. Let's go back to the document here and look at the next thing. So pick, say, 5 random participants from the input data and plot their 50 measurement occasions in one joint plot, but use different colors or something for each participant. So we can see what the data looks like. Okay. I mean, you could plot them all, but it's too many, so we won't be able to see anything. So just pick just a few participants from the input data and plot them individually. So, the first thing is when you the first thing is when you, before taking this class, perhaps would have gone back to your advisor with this result and said, here's what I found from my, study. And then your advisor will look at this and said, like, this makes no sense. How can that be? Right? And then they would send you back to, figure out what's going on. So like now you can skip a week and directly, go to your advisor with something that makes more sense. I've just saved you a week of research. You're welcome. Apparently, you should try Seaborn. Right, let's see. Show me.
I think I'm sure.
Okay. Okay.
I just showed the first 5.
Okay.
You can see nothing.
Can you?
Is
Yeah.
this getting better?
Yes.
Which are things.
Go down to the plot a bit. Interesting. Very interesting. Okay. Interesting. What do we see? Can
All of
you
them,
interpret? Yeah.
everybody has their own baseline speed and typo that things are around. So basically, like all of them have their different
Mistake
person
rates.
level
Hmm.
experience or expertise or something, which we weren't accounting for earlier.
Yeah.
We should account for per person.
Yeah. So some typists are slower than others. Like in general, right? The blue typist is almost always slower than the green typist, for example. And as each individual person types faster,
They have more typos.
like some are less clear, but orange, for example, red, they're maybe trending in that direction a bit. And so in any case, we're not seeing this global trend that we saw earlier, right? So, as a person is typing faster, they maybe make, in any case, not fewer, they maybe make more mistakes, right? Okay. Does anybody else have a different sample? Do you want to put it up?
Are we going to choose 4 participants or 5 in the figure?
How many did you choose?
5.
5? Were there 5 colors?
Yeah. So we only have 4. Yeah, although, now that you said it.
So maybe there's a bug? Yeah, I
No,
remember 4.
I chose only 4.
Okay. Let's see what Marco has. Maybe. Did anybody do a different sample than just the first? You did the first 4 versus actual absolute first 4? Okay.
I did random like
Random 5? Do you want to share also? Or let's see Marcos.
So we got 3, 14, 15, 31, 42.
Can you make that a little bigger?
I don't know if that.
Yeah, nice.
A little bit hard to see, maybe.
Well, yeah, so there's a lot of noise. It's maybe a little hard to see. I mean, the purple pink one.
oh
Sean,
oops.
hit you with a hammer.
Purple pink one looks like they're making more mistakes as they're typing faster. The blue one is maybe about the same.
Yeah,
It's hard to say.
red seems to be marginally slower than else.
the whatever teal one is also kind of making more mistakes as they type fast. Sure. So maybe if some people are more or less about the same, some people are getting worse, right? Making more mistakes as they're typing faster, which is what you would expect, right? Again, what's the mechanism? Huh? So now let's fix this. Oh, do you have a different one? You want to show one too? What is yours? Don't be shy. Go for it. Do you have one? This is all over the place.
I also have some name
Overachiever here.
I don't know why it's scrolling up again and again. I have to scroll it down. Something is happening.
Yeah, so kind of the same thing. Like some people are more or less about the same level of mistakes. Some people are maybe worse as they type faster. Doesn't really look like anybody's getting better as they're typing faster. That's, I think, for sure, from all of these ones we looked at. Okay, very good. So now let's fix this. So yeah, so there's two sources of variation, right, in this data that we're looking at. One is that people who are just better at typing, they tend to make fewer mistakes, right? So some people just make fewer mistakes than others because they're better at typing. So that's one source of variation between subjects. The other one is within subjects. As any one person is typing faster, they tend to make more mistakes, or at least about the same. In any case, not fewer, right? Is what we're seeing. Okay. So there's a group level pattern, kind of comparing individuals with each other. And then there's an individual level pattern comparing observations within an individual. Okay. So this is the kind of nesting or hierarchy that we talked about last time that requires some special treatment. You know, these observations are not independent of each other, right? We cannot pool all 2,500 observations together because they're grouped by individual. Each person is observed 50 times, so we have to deal with that somehow. One solution we saw last time is to model the participant as a fixed effect. So let's try that first.
Was this the method in which we used number of participants minus one variables?
Implicitly, yes, that's what it does. This is the method where you add a variable to your regression. So we had typos as a function of typing speed before. That means you pool all the data together.
Mm-hmm.
So now you're adding a categorical variable.
Which will have n minus one value.
Yes, you're adding a fixed effect for the participant. Which should fix the problem, hopefully. By the way, as an aside, there's different ways to code the categorical variables. The default behavior you get in R, probably in Python, is alphabetic relative to the smallest one. So that may or may not make sense in your case. Another very common way to do this is to say, instead of n minus one relative to the first one arbitrarily, just because alphabetically that's the smallest, or even if you reorder them, instead of saying n minus one relative to one, which makes sense sometimes, you could also alternatively, for example, say everyone against the global mean across all of them. So that may, that depending on what you're modeling, that may make more sense.
The one who's closest to global mean?
the deviation from global mean. So you can code the categorical variables in different ways. The
What was the alphabetical one?
That's the default behavior.
Yeah.
If you do nothing, if you change the way you're doing this, you could, for example, specify it as deviations from the global mean across them, which is sometimes useful. So this is what we just talked about, also default behavior in R. So comparing each level to a base reference level, the one that's alphabetically the smallest by default, unless you change this. Okay, you could do simple coding, which means comparing each level to a fixed reference level. You could do that, if that makes more sense. Right, this depends on your application and your data. You could do this, compares the mean for a given level to the overall mean across all levels. That also makes sense sometimes. Okay. And so on. There's a few more. So
Like that's just the format of the output. The
no,
modeling is exactly same.
no. I mean, you have to change the variables to achieve this. I mean, yes, it changes the interpretation, so it changes the output, but you have to change the input to achieve this. Anyway, that's a distraction. Just remember that it doesn't have to be n-1 relative to the smallest alphabetical one. It could be whatever makes sense in your case. Whoa, nice. Wait, no, that makes no sense. Oh yeah, that maybe makes sense. Yeah, that makes sense. Cool. Let's start with the plot. That looks good. Oh yeah, so this is the global trend between individuals, and this is the within individuals. Very nice. Yeah, so this is what we saw initially, right? When we did the simple regression. We saw this counterintuitive effect that we couldn't explain. But actually at the individual level, all of these regression lines within individual, they're all pointing up. Right? So the faster you type, the more mistakes you make at the individual level. Right? With slightly different slopes. But everybody here tends to make more, not fewer mistakes as they're typing faster. But what we were seeing before, looking at this globally, is just that people who type faster overall tend to make fewer. Sorry. Some people tend to make more mistakes than others. But people who overall type faster are better at typing and make fewer mistakes.
I think because they don't make as many mistakes, they type faster.
They're more experienced. Yeah. Okay, so what does the regression look like? Can we see that? Sorry. Do you have a regression, fixed effects? That was the
This.
yeah. Let's look at this. What's the specification? Num typos as a function of speed. Oh, you've done a bunch of things. Okay, so you've decomposed this into, you've done more here than I was asking. That's okay. Do we have a simpler version of this? You have a simpler version? Let's hold on, Marco, for a second. We'll come back to yours in a second. You have the simpler one? Okay. Let's do Shams first. Yeah, so this is the simplest thing you could do, right? You could just add a variable for participant, a fixed effect for participant in your previous regression, right? And then, as we talked about last time, you get an estimated coefficient for each of the people relative to the first one by convention, means nothing else. And you get a coefficient for the slope. What's the slope?
0.31.
Okay, so now it's positive. It used to be minus 0.6 or something, negative. Now it's positive, which is what we would expect, right? So controlling for the person who is typing, the faster they type, the more mistakes they make. Right? This is similar to the example I had in class on today's Thursday, on Tuesday. Okay, good. So we'll come back to Marcos in a second. I think, yeah, you've sort of deconstructed this. So Marcos is in the bonus tab here. We'll come back to yours in a second. So the other way to do this is, I was complaining about how it's silly to estimate a coefficient for each of these many participants. It uses up variance unnecessarily, et cetera, et cetera. So the alternative was to do a mixed effects regression model. Okay? So I'd like to see that. Can we see a mixed model with a random intercept for participant?
So fixed effect is anything that you are like specifically like you know what it is, right?
Fixed effect is anything that you estimate a coefficient for.
And the strategy here was that because we don't want to do all this unnecessary computation for all these extra 50 or 49 variables. So we said that let's just do it as let's assume there's a distribution, a random distribution of these from which these people have their own means and variances, and we'll just estimate everything from the global mean and variance.
Yeah, so the assumption is, so the fixed effects in the previous model we saw gives you the intercepts, the point on the y-axis for each of the participants, correct? So assuming typing speed is 0, this is how many mistakes, baseline level of mistakes, each participant makes.
So it gives you slope for each. Not in, no? Yes, it gives you percent here.
The fixed effect coefficients gives you the intercept for each participant, or rather the change in intercept relative to the first one. Right? So like baseline level of mistakes for each participant at speed equals 0 before they start typing. Okay? And then you estimate each of those individually. Now we're saying, in the mixed effects, we're saying, let's consider this, let's do a random intercept for participants. So what that means is we're saying, I assume there's some normal distribution of baseline levels of mistakes for all of these participants. And each individual participant's baseline rate is drawn from this normal distribution, okay, as a random variable. So instead of estimating the actual value for each of them, I just estimate the variance of this normal distribution. One parameter instead of 50.
And you can always shift the mean to 0. That's why you don't estimate the mean.
Yeah.
But don't you already know the mean? But the global mean you already know them.
can estimate it from the mean of these, observations, like each.
Oh, but that might not be the mean of the distribution.
But that's what you're estimating. You're estimating that distribution. You're observing this mean, like you're observing the individual points drawn from this normal distribution. So you can estimate all of these things.
No. So like the assumption is that these baseline mistakes come from a random distribution, right?
The baseline mistakes come from a normal distribution.
From a
Yes.
random normal distribution.
Yes.
And we don't know what the mean and the variance are of that distribution. So we estimate the variance,
Yes.
but we don't estimate the mean. Why? Is it because we know what the overall or sample mean is? Or because that's not of interest, because you can always shift the mean to 0 and then
Ask the mathematician. I don't know. I'm not sure.
Okay.
Ask Claude. Yeah, it's a good question. I don't know why you don't care about the mean. I'm sure Claude will. Please tell us what you learned. So by estimating the variance of this distribution from which these individual level intercepts were drawn, which of these things are you estimating, if any? What's the relationship between what I'm asking for here in my prompt and what you're estimating within this mixed effects regression? We'll come back to this question. Seems confusing. We'll come back to this in a second. Does anybody have the concrete mixed effects model that we could look at? Anybody willing to share? No. Somebody other than Sham. He's too eager. The thing you did earlier, Marco, is the bonus question in my doc. It's sort of so with the mixed effects model, you could do these two things at the same time. With the fixed effects model, you cannot do both of these things at the same time. With the fixed effects model, you can only do the within participant, bits between participant variance, I guess.
So you're saying like you can only take one participant at a time?
You cannot model at the same time the between group variance and the within group variance with the fixed effects model we had before by default. So your hack is how you can do both at the same time. Sure. The mixed effects model gives you both at the same time by default without any hack. But your hack is a way to do that without running a mixed effect.
wasn't that the mixed effect model, whatever Marco was showing earlier?
No. Mixed effect model needs a random effects term. So that would be, it would be this typos.
Yeah, speed within speed mean.
Speed plus 1 bar participant. This is the syntax that says 1 is intercept. So random intercept for each for participant, random intercept for participant. And this whatever parenthesis syntax is what gets you that. You would also need to do library LME4 instead of the default one. So this will be Elmer. You could do this. In fact, you should probably do this. Because this gives you p-values for the estimated coefficients. The one we had before was just The one we had before was this, right?
Typos, speed plus factor.
By the way, yeah. But the point is, so participant we modeled before as a fixed effect. Now we're modeling it as a random intercept. So I want to see one. We're going to run out of time soon. Can anybody share one, please? Anybody that's not Sham? Or Marco, because he was also very active. Anybody else? Huh. Anybody that is Sham or Marco?
No.
I think I'm wondering right now. I'm already.
I'm already on that bonus, so.
You don't think yours is what?
So I just don't think mine's right, so I guess it's time for me to log in and share.
I really want you to be confident in this part here, because it's the basis for everything. Like if you are confident with this kind of stuff, you will be invincible. You can figure out all of the other things that follow, all more sophisticated types of regression and so forth. They're all variants of this. Like if you're confident with this, you could do anything.
Do you have any online resources that just like practice this?
I think ask Claude to draw you a tutorial or something. There are countless. I list some books that I like. There's a, I don't know, R or data science in R or something book that I like. It's listed in one of the lecture slides from last time or something at the beginning. There's a few, but I mean, these days I don't think I don't think you need sort of dedicated resources. You just ask a chatbot to make you teach you something. Right, let's see one. Come on. Chad? Marco? Oh, sorry, my bad. I was in the wrong window. Okay, so not this one.
Yeah, give me like 30 seconds.
So like where does this come from? Like, is this the chatbot thing, or like I didn't ask you to do this yet? Where does this
So I was understanding how this works with my chatbot, and now chatbot said this is what data response is. Hence I asked those questions about speed, variance.
this is a teachable moment. I do want to come back to this thing, which this way does not make sense.
Okay.
But let's come back to that.
This is what you wanted.
Yes. Okay, cool. So read this for me. This looks good.
So what this means is that for every unit increase in typing speed, there are 0.3 more typos. And the baseline is 0.0.
This is like before. Remember the fixed effects one from a few minutes ago? Right, so as typing speed goes up within individuals for each person, mistakes go up by 0.3 for every whatever unit increase. Right, so as you're typing faster, the same person, as they're typing faster, they make more mistakes with this slope, which is the same thing we saw before. Okay, so this gives us the individual level pattern, right? So within individuals, this is the pattern, right? Now this here, random effects, standard deviation. So what's the relationship between variance and standard deviation? Which one's square root of which?
Variance is the square of.
The standard deviation. Okay, yeah. So this thing, the square of this thing is the variance of the distribution, normal distribution, from which we drew the random intercepts for participants. Okay? So this is the between participants, between group variance. The other thing I was asking about in my prompt. Okay, so here we're saying the normal distribution from which we randomly draw these participant level intercepts has this standard deviation and corresponding variance. Okay, that gets estimated. I like you should use Elmer instead of LME. Gives you better output, I think.
Yeah, I had some installation issues. L1, yes. So.
Okay. Okay, this is a good time since we're over. It's a good time to pause and maybe get some questions. The stuff you're here.
On that document, can you also list what Marco was doing? Because I think that is also mixed effect.